All right, you asked for a video and you got one, so hopefully you learn a lot from this video and you just feel like a better person after you watch this, and hopefully you're not too critical of me when I mess up and laugh at me, especially you, Jack, because I know that sometimes you get mad when I mess up, and it's okay because we're all human, and I hope that you can forgive me. But I also hope I don't make any mistakes because I don't know how to rewind on this thing. And anyways, so we'll see. All right, so we're going to do a power and error question together where we're going to go through type 1 and 2 and consequences, and then also calculate power and error and type 1 and 2 and probabilities and things like that. So here it says the city council in a large city has become concerned about the trend toward exclusion of renters with children in apartments within a city. I hope they would never do that with puppies. The city decides to test the hypotheses. So it gives me 75%, greater than 75%, where P is the proportion of apartments that prohibit children. Wow, that's a lot. And then use a significance level of 0.05. So that means that alpha is 0.05. Remember, alpha is type 1 error. So if I were to state the type 1 error, that remember that means when you reject the hoe, but the hoe is true. So if I were to put this into context, I would say if I were to reject the null hypothesis, then my conclusion would say there is sufficient evidence. Sufficient evidence to suggest. My pen is doing weird things. Suggest that the proportion of apartments that prohibit children is greater than 75% or 0.75 when in reality it is equal to 75%. And we just say equal, don't say less than or equal, because the null hypothesis is 0.75. So equal to 75%. We don't really get into less than or equal to in this class. If you take a college stats course, then your null would be less than or equal to, but we just say equal. And then a consequence of that, so this you just come up with on your own. So let's say that maybe a renter with a child may miss out on an apartment, on leasing an apartment because they think no children allowed. Also, maybe like the apartment complex may miss out on business because they allow children, but people think they don't. You could say that as well. That might actually be a better one, but I've already written this, so either one is fine. Remember that consequences you come up with on your own, and as long as you can justify it, then the AP graders will say it's okay. A type 2 error is whenever you fail to reject. So fail to reject the hoe, but the hoe is false. So I would say, I'm going to use purple. I would say there is not sufficient, cannot spell, sufficient evidence to suggest that the proportion of apartments that prohibit children, oh my goodness, is greater than 75% when in reality it is greater than 75%. So if I were to recap kind of what I did, you would say there is sufficient evidence to suggest there is sufficient evidence to suggest when in reality, ho. So, ho. And then for type 2 error, there is not sufficient evidence to suggest when in reality, ha. So, ho. You can think about that. Ha-ho. And type 2 is ha-ha. Ha-ha, you made a type 2 error. Consequence of this, maybe, let's see, renters with children are denied a home. They're homeless. They have no food. And then they live on the streets. And that could be really bad. So renters with children are denied a home and are homeless. That was very dramatic, but it's true. This is so sad. So these are type 1 and type 2 errors, and then consequences. Then it says, which is more severe? Does that affect how you choose your significance level? I would say type 2 is more severe. Definitely type 2, because we don't want anyone homeless. And then type 2, because families may not find a home. That is so sad. Find a home. Does this affect how you choose your significance level? So remember that a type 1 error, so type 1 is alpha, and a type 2 is beta. We also know that they do have an inverse relationship. They're inversely related. So since they are inversely related, I choose alpha. Remember, I choose alpha. So I'm going to choose a larger alpha. I'm going to sacrifice my alpha. So beta will be smaller. And then I have a smaller probability of making a type 2 error. And since that is more severe, I want to choose a larger alpha. Okay, number 3, it says, what is the probability of a type 2 error and power when the alternative proportion, that's what I call this, alternative proportion. Basically, that means whenever I took a sample, I got 83%. So if we look at number 1, we remember that if I were to draw my normal curve, I was centered at 0.75, and I used an alpha of 0.05, right? And so that means that all of this is 5%. So I need to figure out what is this number at the 95th percentile. And then, so if I were to figure that out, I would go to my calculator and I would type in normal. Nope, I wouldn't. I would not do normal CDF. That is a lie. I would do inverse norm. And I'm going to type in the 95th percentile because this is 0.95. My mean is 0.75. And then my standard deviation I calculate by doing the square root of 0.75, 0.25. And they didn't give us a sample size, did they? They did not. So I'm going to say that it is 100. I just made that up. I'm going to make that up. It's 100. And I'm going to put this in my calculator. And I am going to get, and you should get 0.8212. I forgot my calculator at home, so I had to download this app on my phone for an 84. It was like $10. One of the best investments I've made, I think. It's pretty cool. Okay, so this number right here is 0.8212. I'm going to draw my little line down. So basically, this is my rejection region. If this is 0.8212, that means I'm going to reject the null hypothesis anywhere past that point. And so here it says that my alternative hypothesis is 0.83. So I'm going to draw a new normal curve right here. My center is going to be at 0.83, right? And so anything that is to the right of this Okay, there was like a minor error, but I tried to put everything back. It was so weird. Sometimes I hate technology. Okay, anyway, so we have our new normal curve drawn. This is my alternative proportion, so this is at 0.83. Right here, this is 0.8212. That's my rejection region. Anything to the left of that is going to be beta, which means that I made a type 2 error. Anything to the right of it is going to be power. And so we know that power and beta have an inverse relationship, and power equals 1 minus beta or power plus beta equals 1, because you either rejected and you got the right decision, or you made a type 2 error and there was no in between. So if I wanted to find the probability to the left of this, so let's say I wanted to find the probability of a type 2 error, then I could use normal CDF. So that looks like EDF. Normal CDF of negative infinity to 0.8212. My mean is now going to be 0.83. And my standard deviation is the square root of 0.83, 0.17, and my sample size that I made up was 100. So when I type that in, you end up getting, if you want to try this with me, you end up getting 0.4076. So beta would be, which is type 2 error, beta would be 0.4076, and then power would be 1 minus 0.4076, which would be 0.5924. So this is how I would calculate beta and power, because power equals 1 minus beta. So don't forget that. It is not alpha. Power does not equal 1 plus alpha. It is beta. And I made a mistake last time and told you the wrong thing. But it is this, I promise. Okay, next example, it says researchers want to test the hypotheses greater than 0.6. Suppose the probability of making a type 2 error, which we would call beta, is 0.15. What is the power of the test? Remember that power plus beta equals 1. So I would just say power equals 1 minus beta, which is 1 minus 0.15. So you would get 0.85. It is as simple as that. Okay, lastly, I want to fill out this chart and I want you to memorize it because I think this is one of the most important tools that you can use. And I would try to make the chart and then also draw this chart, and you will not get any test questions wrong, I promise, if you can memorize this right here. So remember that type 1 and type 2 error. Type 1 error is alpha. Type 2 error is beta. And type 2 and power have an inverse relationship. They are inversely related. So if beta goes up, power goes down, vice versa. Also remember that type 1 error only changes. So alpha, I'm going to put this at the bottom. Alpha only changes when you change it. So it only changes when you actively change it. Because I am choosing alpha, therefore alpha is not going to change unless I move it myself. So if you increase alpha, then alpha will obviously increase. But if I increase my sample size and if I increase the difference between null and alternative hypothesis, so what this means right here, this is distance from null hypothesis. So like let's say that my null hypothesis is 0.75 and I take a sample and I get 0.83. It's like the distance from your null hypothesis proportion to alternative hypothesis proportion. So like the more distance that you are, the further away you are from the null hypothesis. So if I change both of these things, my type 1 error are going to stay the same. Because remember that the only time that alpha changes is if I change it. So I can increase it, I can decrease it. But if I change my sample size, or this is sample size, or if I change the distance from my null to alternative, my alpha is still going to stay the same. If I increase alpha, then that means that my beta is going to decrease because they also have an inverse relationship. So alpha, beta have an inverse, and beta and power have an inverse. But alpha and power have a direct relationship. So if I increase my sample size, then that is going to increase my beta. And if I increase my distance from the null hypothesis to alternative hypothesis proportion, that is also going to increase my beta. And the reason why I probably should have done power first is because if I increase my type 1 error, that's also going to increase my power. If I increase my sample size, that's going to increase my power. And then if I increase the distance from my null hypothesis proportion to alternative, that is going to increase my power. And so then, probably should have done this first. Since these have an inverse relationship, it's going to decrease all of these things. So essentially 3 things increase my power. Increasing alpha, increasing sample size, and increasing the distance from my null hypothesis to alternative. But once my power increases, that means that my beta decreases. So I want my power to be higher and I want my beta to be lower. But remember that my alpha only changes when you change alpha. So I would memorize this chart and then also memorize the other chart that talks about what a type 1 and type 2 error is. And then you should be perfect for the quiz.